Alright, back with a fun one this time. Question 4 from review set 12b. Find the cosine function represented in the following graphs. Well, this is just the first one here, A. So this is like a little bit of detective work. It's a bit of fun, a bit of breaking down the code, trying to figure out what's going on. Remember, there's always multiple answers. There's a number of ways you can do this, but I'm going to show you the way that I would think this one's the easiest to identify and figure out. First thing, we can find the amplitude really easy. I don't have a vertical shift because my central axis is right along the x-axis, so that's good. So D is going to be 0. That's easy enough. And my amplitude, I'm going up to 4 and down to 4. So clearly I've been stretched by a factor of 4. So I'm going to make a little note of that. I've got an amplitude equal to 4. Now, what else have I got? The period is how long it takes to repeat. Now, it looks to me like that's one there and another one here. Looks like it's taken 2 pi to repeat. So the period is in fact the 2 pi to repeat 2 cycles. So the period is only pi. That is pretty atrocious writing, Chewy. Let's go back and fix that up. That just looks ugly. I said in the last one I've got to be more confident and just write faster. So the period, well, maybe I was lying, equals pi. Therefore, remember, 2 pi divided by b must equal pi. Remember that b in our a sine bx plus minus c plus d, you know the general form. 2 pi over b is how we find out the period. So in this case, if the period is pi, that's implying that b must equal 2. Now, we've got to decide whether we want a horizontal shift or not. We could say it's a sine curve, and the horizontal shift that shifted, well, if that's pi after one complete cycle, that'd be pi over 4. So I could say it shifted pi over 4 to the right. I could say it's a cosine curve and it shifted by pi over 2 to the right. That would also be possible. But my favourite way of doing these ones, and I love them, when you start down the bottom, go to the top and go back down, it's the exact opposite of a cosine graph. So the cosine graph has been reflected in the x-axis, turned upside down. How do we do that? That's right, we make the amplitude negative. So if I was going to do this one, I would say that y equals, it's a negative cosine graph, negative 4 for the amplitude, cosine x, but the amplitude we said b was 2, so it's negative 4 cosine 2x. No plus d, no transformation at all. Horizontally, that's it. We could do those other ones that we said. What else could we say? Y equals 4 sine, 2 sets of brackets, 2x, and if we wanted to move pi over 4 to the right, I've got to write minus pi over 4 here. And we've got that one. Or I could just as easily say it was the cosine graph. Y equals 4, not a negative cosine, but a cosine. Cosine, remember the 2 outside the brackets. And cosine graph shifted pi on 2 to the right, so it's x minus pi over 2. That will give me a transformation of pi over 2 to the right. If you type them into Desmos, you'll find they're all the same. See you in the next one.